Well, hello, meteorologist Nick Johnston here. For a long time, I've wanted to do kind of a look-back piece on the historic storm that hit the capital region and surrounding areas, New England included, back on October 4th, 1987. It was a very memorable storm for me growing up, and any longtime residents who were here at the time know why. And since today is the 30-year anniversary of that incredible storm to the day, I wanted to do a little bit of a look-back piece. Hey, real quick, I wanted to talk about this Times-Union here. The newspaper, this is an interesting story. Times-Union, on October 4th, when this snowstorm hit, the Times-Union lost power. So this newspaper edition never would have happened but for a gentleman's agreement with the Troy Record newspaper, their competitor, who volunteered to let them print this edition at their house. So pretty neat. Just try to imagine that, you know, if CBS 6 went dark and Channel 10 said, well, come on over, we'll let you do your newscast from here. That's a pretty amazing story in and of itself. But that's why the Times-Union here looks a little bit different, not the normal header. Okay, so here's what I want to be covering in this historical look back. The rundown. First, a quick introduction to the storm. I want to cover what sources I used because there were some other meteorologists who did a lot of work. And I've piggybacked off of some of their research. Also, I've got a lot of photos from the Times-Union, a few other sources. Why was this storm historic? What made it worth talking about 30 years later? I want to go through the local photos to show everybody who might not be familiar with this storm what it looked like. I want to go through the storm development using some historic weather maps to show you what exactly the storm looked like as it was gaining steam. I want to walk through the storm timeline, talk about the snow totals, which are pretty remarkable. You're going to like that map. I want to talk about what made it unexpected, right? How did this storm catch forecasters and most of the region totally off guard? And to do that, I got to talk a little bit about cold dome and diabatic cooling effects. Have I lost everybody yet? That's a little bit nerdy, but I'm going to try to go through that fairly quickly and make it understandable as best I can. Then I want to answer the question, could it happen again? And wrap up with a conclusion. So, okay, special thanks now to Jonathan Finch of the National Weather Service for doing a really pretty amazing storm analysis. It was several years ago that he did this analysis, but that's where I got some of these weather maps that I'm going to be using. So, yeah, really appreciative to the work he did, Jonathan Finch. The Times-Union also did a pretty amazing job of covering that storm, photo documentation there. And so with that, I've got to also give a shout-out thanks to the Troy banner, or the Troy Record rather, the Bennington banner. Photo documentation there also pretty amazing. And my parents, I want to give a special thanks to them for putting this storm in a positive perspective. You know, at age 5, they could have handled things a few different ways, but it ended up being a really positive experience for me. So, okay, what made this storm worth talking about? Well, a couple of really important points here. One, it was the earliest snowfall that ever happened in Albany. Ever. There's never been snow on October 3rd. October 4th is the earliest it's ever occurred. And this obviously was not just a light flurry of snow. No, this dumped 6.5 inches on Albany, more than 20 inches on other parts of the region, and it ended up being the biggest snowfall to ever happen, not just for the date, not just for October 4th, but for the entire month of October. Now stop and think about that. If you were going to guess when the biggest snowstorm to ever happen in October would be, well, you'd think it was the end of the month, right? Nope. Biggest snowstorm ever happened at the beginning of the month, which is pretty remarkable. The storm occurred, since it happened so early, when all of the trees still had their leaves, or at least most of the leaves. Well, look outside right now. Still most trees are covered. And it was even near peak foliage. So, first of all, the leaves being on the trees, that's why thousands upon thousands of trees came down. But also just the juxtaposition with the color, the oranges and reds coming through with the snow. Very weird kind of scene unfolded that day. The trees came down by the thousands, causing widespread power outages. Many residents, and I can vouch for this, I remember this growing up, on that morning and into the early part of the afternoon, the trees coming down just sounded like guns going off. I mean, just one after another, or loud firecrackers. About every 10 to 20 seconds, there was just another huge crash and boom. And we're not talking about small twigs and branches here. We're talking about giant limbs and tree trunks, whole trees snapping in half. So that's why we're talking about major, loud crashes and booms here. Again, adding to that very eerie, almost surreal kind of a day. So between 250 and 300,000 people were without power. Roughly 250,000 people in the dark. Some of those people were in the dark for as much as 2 weeks. Now the capital region, the immediate Albany area, went dark for about, well, my house, we were growing up near Stuyvesant Plaza, we were dark for about 2.5 days. Some of the hill towns outside of Albany were down for 1 to 2 weeks. In the U.S., the year with the most injuries from snowstorms, guess what? 1987, with the entire year injuries from snowstorms totaling 658. But here's the thing, about half of those came from this one storm. About half of those injuries coming from the October 4th snowstorm in New York and New England. About 20 deaths were attributed to the storm. Now, a few of those were from traffic incidents, but a number of those deaths were from falling trees, just crushing unsuspecting people. That's when I say the giant tree limbs were coming down, I mean they were coming down all over the place. And yeah, they were doing damage to houses, property, cars were smashed, and occasionally, yeah, people were injured. And the other thing that made this storm so historic is the fact that it was unexpected, right? The forecast the night before was for a cold, rainy day. And this was not that. It was a heavy, wet snow event. So yeah, that was one of the big parts of this storm, is that it took everybody by surprise. Some forecasters included. So that's one of the reasons that this was such a big storm. It was so early in the season and so unexpected that some snowplows hadn't been fully outfitted yet, just adding to the challenge of trying to get things cleaned up. So without further ado, I want to get into the pictures. I'm going to step out of the way. These first few photos coming to us from the Bennington Banner. I love this shot. Look at that. I mean, I think if you look at that gentleman's expression, I think that went for a lot of people on this snowy morning. Look at that, just looks miserable. And that line of cars, yeah, traffic obviously at a crawl. Here's another shot from Bennington. Look at those trees coming down. This was a common sight. Traffic officer. Boy, I'd love to be a fly on the wall here. Wonder what, I wonder what this exchange was like. The flakes still flying. One other thing to take away from this picture, look at the truck in the background. Look at how deep that snow is on the roof. That looks like about 20 inches. And Bennington was one of the places that did get 20 and even 20 plus. Another shot from Bennington with trees coming down, low visibility. And this shot. Hey, where are you going? Nowhere. That's where. And this was true of a lot of places. Roads were closed. Many roads were impassable. So, yikes. I like that this guy still seems to have a positive attitude. Now I want to spend some time looking at the Times-Union, because they also did a terrific job of covering this storm. These are more from around the capital region. Look at that slush, how deep that slushy snow is here. This is on Central Ave and Manning Boulevard in Albany. Yikes. Hey, this is one of the more iconic shots, I think, from the storm, and this one also from the Times-Union. This was near Washington Park in Albany, where a gentleman getting around. Smart. Perfect. Yep. I think you're better getting around on skis than trying to drive on a day like this. And yeah, he's in a good mood, and why not? Get the skis out of the closet a little early. Yikes. This was from the Albany County Airport. Again, Times-Union. Nasty. Look at that snow piling up. And one of the things about the storm was how quickly the snow was coming down. The intensity of the snow made it nearly impossible to keep up with. And you can get a sense of that looking at this car. Just, yeah, I mean, mess trying to get cleaned up and dug out. And again, a shot of how deep the slush is here on State Street and Pearl Street in Albany. Messy, messy conditions. And this is a great shot. This was wedding day in Wineskill. In the background there, there's the groom and the groom's brother. And yes, Times-Union did a little follow-up on this story. Really cool story here. Yes, the bride and groom did follow through, though a number of their guests had to unfortunately cancel. They did get married on the 4th, despite the snow. I mean, look at this limo just surrounded by thick snow. It doesn't even look like this area has been plowed yet. And now there's this. This is Marie and Phil Hanby, 25 years after that fateful day on October 4th, 1987. The Times-Union did a follow-up piece with them, and just a really cool little story. They're still together. They got married on the 4th, and look at this photo. Happy couple with a giant snowbank in the background. And now this was on the 25-year anniversary of the storm, and that behind them is what October normally should look like. Right? So the difference between these two photos is amazing. That's their son in the background. So very cool, and again, congratulations to the happy couple. What a neat story to be able to tell. Here's another from Western Ave in Albany. Looks like that tree is coming down as this photo was being taken. Now, here's a really cool photo too, and there's actually a lot of information you can take away from this. First of all, look at the street. So the snow appears to have mostly melted away. It has also been plowed. Lady walking down on what's wet pavement right now, not icy at this point. Now, you can see the snow off to the side. Pretty heavy and deep snowbanks here, but also notice the branches mixed in. A lot of these trees were dropping their limbs here on the sides, some of those coming down on some of the parked cars on either side of the road. But there's also this. If you look closely, you'll notice long shadows. So the sun broke out in the later part of the day. So, I mean, just think about all of the things that happened on October 4th. We got blasted with heavy snow, breezy, cold conditions, and then we finished the day with the sun breaking out and that snow starting to melt away. Remarkable. Now, this was interesting too. This coming out of West Sand Lake, one of the areas that got really hit hard, and this was dry ice. Yeah, West Sand Lake lost power for, well, I don't know, parts of West Sand Lake for about a week, I believe. And with power out for that long, fire department was handing out dry ice to the public so that they could put it in their refrigerators just to keep their food cold because they were without power for so long. What a wild concept. And obviously, I mean, they're being careful handling that with gloves. And look at the line out the door. Look at this. Yeah. That's how many residents were going to be without power for quite a while. It was going to take a long time to get this power back up and running just because of the number of power lines and power poles that had come down. Those all have to be replaced. And that's why it took forever for some communities to get their power switched back on. Just amazing. All right, now I want to walk you through what this storm looked like. This is 11 p.m. on the 3rd of October. This is the night before. Keep an eye on this area of low pressure. Moving up the coast. This is at 1 a.m., now on the 4th. Now at 1 a.m. it was still mostly rain. But in the early morning hours, as this storm got a little bit further north, cooler air started to pool down the Hudson Valley, and that allowed a changeover by around 3, 4 a.m. from rain to heavy snow. And it stayed heavy snow then for about the next 10 to 11, 12 hours for much of the first part of the day. This low, this is at 3 a.m., now 5 a.m., entering into the New England coastline. This is at 7 a.m. The storm backed inland a little bit. This is now 9 a.m., starting to track north, and at 9 a.m. we were still in the thick of that snow, still getting hammered at 9 a.m., still getting hit pretty hard at 11 a.m. As that storm pulled away, though, things did diminish. Now, this is 1 in the afternoon. It was still snowing at 1 p.m. in Albany. But by 2, 3 p.m., it shut down quickly, and as you saw in some of those photos, the sun ended up breaking out in the later part of the day. All right, now here's the satellite image. This is 8:30 in the morning, so this is really, we were getting hammered at 8:30 in the morning, heavy snow. This is what it looked like on the satellite. Look at that, strong cyclone. You can see the rotation around this storm pretty clearly defined right off the coast. Powerful cyclone here. And again, it was spreading a lot of heavy rain and moisture inland. And the temperatures were just cold enough to convert that heavy rain over to what ended up being very heavy, wet snow. So let me show you the timeline of this storm, because really the 3 days tell you a pretty interesting story. First of all, on the October 3rd, the day before, high of 60, low of 39. Now just a reminder, the normal high would be 65, stayed a little bit below that, but 60 is pretty normal for early October, right? Low of 39. That's a little bit below normal, but also still pretty typical for that time of the year. We did get heavy rain on the 3rd. 3/4 of an inch of rain, and that's important to note. Rain was still coming down heavy in the early morning hours of October 4th, and there were a lot of puddles Lots of standing water. Now think of that. You can probably remember a time where you saw snowflakes falling and they were landing in puddles, and what was happening? They just melted immediately, right? No accumulation, just instant melting. So that was happening when the change from rain to snow occurred. For the first while, that snow was just melting on the ground. Temperature high for October 4th was 44 degrees. The low was 33. That's important to note. At no point during that snowstorm did it actually get to 32 degrees in Albany. It never got to freezing. We stayed above the freezing point throughout this entire snowstorm event. 33, the coldest it got. So we got 2.82 inches of water. Now think about that. 2.82 inches of rain. That's incredible. Alone, that would almost be enough to cause flash flooding. And with that, mixed at times, was 6.5 inches of very, very heavy, wet, slushy snow that fell in Albany. Now, honestly, I think these numbers might be just a little bit off. And I'm going to explain. Measurements within this storm were one of the problems. I would guess that this liquid number might have actually been a little bit lower, and that snow number might have been a little bit higher in Albany. What's giving me that impression is a lot of the hill towns around Albany were closer to 10, 12 inches of snow, and a lot of places saw a little bit less of that reported rain. That is a ton of liquid equivalent. So I think maybe the snow was a little higher, the water was a little lower. Anyways, we got a big walloping storm here mixed with rain and snow. And then on the 5th, high of 61, low of 30, no rain, no snow. It was dry and partly sunny on the 5th. So now here's an actual breakdown of the 4th itself. What weather conditions were happening at what hour? At 1 a.m. in the morning, it was 38 degrees, with rain coming down pretty good, moderate rain. Winds at that hour were 15 miles per hour, and notice it stayed breezy for much of the day. That's a part of the equation. And the direction of the winds is also an important part of this equation. That north and northeasterly wind reinforcing that cold air at the surface. By 4 a.m. we were at 34, and the rain had started to mix. Rain, snow, and fog were all being reported at the Albany International Airport at that hour. 7 a.m. we were dropped to 33 and stay at 33 degrees into the early afternoon. It was through this period, between around 2, 3 in the morning and around 2, 3 in the afternoon, that we got the entire bulk of this storm over about a 12-hour period. Now, when you remember that some parts of the region got about 2 feet of wet snow in 12 hours, that's pretty amazing. Snow and fog were continued to be reported at 1 p.m., but by 4, the snow and fog were gone. Temperature had jumped to 39 degrees, and we were starting to see sunshine. 7 p.m., it was 44, our high temperature for the day. So this was a wacky day for a lot of different reasons. So how much snow actually fell on parts of the area? This is pretty interesting, and it's one of the reasons that this was a really challenging storm for forecasters to cover. Now, let me pull up the snow map for you here. All right, and I want to zoom in a little bit closer so you can see exactly who got what, because it really is pretty amazing when you see the big differences. Okay, so here's a closer look. I want to start to the north and we'll work our way south. Okay, look at this. So near Manchester, Vermont, 18 inches of snow. Meanwhile, Salem, New York, only got about 6. And look at this. Near Milton, they reported 1 inch of snow. Up near Glens Falls, also 1 inch of snow. Let's head a little bit further south, including now parts of the capital region. Albany, remember, officially reported 6.5 inches. But if you look around the Albany area, there's a lot of 10, 12, 14-inch readings, and that's why I think that snow total might have been on a little bit on the low side for Albany. But look at what happened as you headed into the higher elevations, the Taconic Hills of eastern New York, the Rensselaer Plateau, Bennington County, Berkshires, and into Litchfield County. Those were the areas that got hit the hardest. Also into Dutchess County, a little bit further south in New York. Look at these numbers, 27 inches. This is Wynenskill, 22. Just amazing. And especially amazing is when you consider how short a distance this is. Remember, Albany reported 6.5 inches. Near West Sand Lake, only about 6, 7 miles away from Albany, they were reporting 20-plus inches of snow. So we go from 6.5 inches to 20 inches over about a 6-mile span. That's just unbelievable, right? So obviously, pinning down an accurate snow totals forecast would have been a real challenge, and that's if they had anticipated the snow. So again, we're talking about teens and 20s in these areas. Small differences in elevation made a huge difference in terms of the snow total. Let me head further south now. East Greenbush, about 20. Pittsfield, about 12 to 14. Near Chatham, 20 inches. Also, near Hunter Mountain, the Catskills got it pretty good as well. Near Hunter, they got 22 inches. We head inland a little bit further. Yeah, 17, 10, Pine Hill, 21. And even a little bit further south now, it was still coming down heavy. Down further south near Arlington, they got 14 inches. Dover Plains, 12. And into Litchfield County, it ranged from 12 to 20 inches of snow. So that's kind of an overlook of the map here. Now I want to zoom out and show you what a different look of the map shows. This is maybe a little bit easier for your eyes to pick up on. In light blue, that indicates where we got 6 to 12 inches. And that included much of the capital region. But once you hit the hill towns, all bets were off. We jumped from 6 to 12 to 18 inches in blue. Also notice the tight grouping of these lines. That's because of the quick ramp up in snow totals. In purple, that's 18 to 24 inches, and anything in red, that's where some places got 24 inches plus 2 feet of that wet snow. Just amazing when you look at this map. And outside areas barely got anything at all, where it stayed mostly rain. Okay, so let's talk a little bit about some of the weather features that caused all of this to happen. I want to get back into PowerPoint here. Here we go. So what gives? How did this happen? Why was this storm so unexpected? Well, one of the reasons this storm was so unexpected is because there was no historical context for this storm. It was the first of its kind. There's never been another storm like it, so there was nothing to compare it to. Climatology also would have been against this happening. The normal high temperature being 65, the normal low being 44. So if you were a forecaster and you were looking at the likelihood of a storm like this happening on October 4th, you'd say, probably not likely. Same storm, if it happened in November or December, would not have been as big a story. It would have been normal. The trees would have already lost their leaves, wouldn't have been as big a deal. But the fact that it happened so early made the storm extra unlikely. And also, the recent weather that had happened also contributed to the storm really not being a good probability of panning out. We're talking about warm temperatures in the days leading up to this, leading to unfrozen ground. The ground was not frozen, allowing that snow to melt once it landed. And of course, as I mentioned, there was the rain with those puddles also contributing to that snow melt. So there were a lot of factors working against this storm. Then there were some equipment issues. Models missed some key information, namely the cyclogenesis, the intense, significant cyclogenesis that was happening off the East Coast. The models missed when exactly this storm would initialize. It also missed the intensity. Melting snow made it very difficult to get accurate measurements of this storm. There was a layer of slush that developed underneath the snowpack, which made it very complicated to get an accurate snow measurement. There were also big gaps in the snow reports and the spotter network across our area in especially hard-hit areas. So some of the places that got the most snow weren't giving a lot of snow totals. That was also an issue. And again, the snow plows not being fully outfitted was also a bit of an issue there. I mean, some of them were, but it wasn't like they had been fully prepared for a winter storm at that point in the year. And you can understand why. Then there were some forecasting challenges, we'll say. Extremely temperature and elevation sensitive storm. Those are always really tough for forecasters to handle because sometimes, you know, a change in a degree, maybe only half a degree, could be the difference between, you know, a colder, mostly rain or versus very wet and heavy snow. So small differences like that can be a very big challenge for forecasters. There was also incredible differences over short distances. That's what I was talking about with the 6.5 inches in Albany ramping up to the near 20 inches near West Sand Lake and Winenskill. Yeah, Winenskill, 6 miles away, got about 22 inches. That's just amazing. Snowfall rates at times approached 5 to 7 inches per hour. Now that's also remarkable. That's blinding. 5 to 7 inches per hour. That's remarkable. And that is the reason that this snow that otherwise would have melted on the ground was able to accumulate. It's because it was coming down too fast to melt. Liquid snow ratios. Now this is something that's been debated, but we know it was very, very wet snow. A normal water to snow ratio is about 1 inch of rain equals about 10 inches of snow. That's normal. It depends on the temperatures though. 1 to 3.5, that's less like snow and more like just dumping a slush puppy on the capital region. It's you know, a mix of snow and water. It's basically sleet that's coming down. Now some people say 3.5. I don't think so. That number sounds a little bit too low. And again, one of the problems with this storm was getting accurate measurements, but we know it was a very, very high water content. So even if it wasn't down to 3.5, 1 to 5, 1 to 4, it was very, very wet snow. It happened, and here's something you might not have thought of. One of the reasons we had problems with this storm, it happened on the weekend, when staffing is a little bit lower in the news. Channel 6, Channel 10, Channel 13 didn't have as many people on staff to cover this storm. Same thing generally goes for the National Weather Service. Less staffing meant fewer eyes, fewer forecasters watching this storm. You know, maybe if there had been more people tracking the storm, someone might have noticed, hey, what about this? What if this happens? But on the weekend, there's fewer people to forecast that storm, and that's one of the reasons that this storm may have been misdiagnosed. And then there was the fact that some of the forecasts just failed. One was the fact that the temperature forecast was too warm. It got colder than it looked like it would, and that's why we saw more snow than rain. There were two important reasons that happened, and I'm not beating up on forecasters here. I mean, these two reasons it was colder would be very, very difficult to pick out. The first, there was a cold dome of air that developed at the surface. I'm going to spend just a second explaining what that is in just a minute, but basically it meant that there was a pool of cold air at the surface, cold enough to make sure that it stayed snow for several hours. And also then in the upper level of the atmosphere, there was a process known as diabatic cooling happening, and that was keeping the upper levels of the atmosphere just cold enough to maintain those wet flakes of snow. So let me quick kind of delve into what first the cold dome is. That's where a cold air mass kind of gets stuck at the surface and basically gets locked into place. If you think about this mountain range as like the Catskills and Adirondacks and this valley as the Hudson Valley, it gives you a good sense of where we're oriented here. Winds, remember, were out of the north and northeast, bringing in colder air out of the north, and that north-northeast wind banked up against the Catskills and Adirondacks and got stuck in the valley. Getting overrun by some warmer air, this cold air mass got trapped. Remember, cold air sinks, warm air rises. So with this cold air in place at the surface, it just wasn't going to go anywhere. And that wind, remember, was breezy, kept reinforcing this cold air at the surface. So that's the cold dome that developed at the surface. Now here's a look at what that diabatic cooling process is. It's actually a little easier to understand than it might sound. Diabatic cooling, you think of the evaporational cooling process, everybody knows that. Well, there's also a similar process when you go from a solid to a liquid. When that happens, it absorbs energy from the surrounding air. And what was happening at the time was those snowflakes in the air were melting. Temperatures were above freezing. So the snowflakes were melting. That melting was absorbing energy from the surrounding air, and the net result was the atmosphere was cooling due to that melting snow. Now, normally this process, diabatic cooling, there's probably not many people that have heard of this before, and that would be expected. This is not something that meteorologists would talk about much, because normally diabatic cooling does not play a big role in what happens. Normally. Now this was obviously the exception to the rule and would have been really difficult to pick out in advance. But yeah, normally things like what type of air you're bringing into the region, what the winds are carrying. Is the air coming into your area warm and humid? Or is it cold and dry? Normally that would have a much bigger impact on what type of precipitation and weather you'd see than the diabatic cooling process. And also then a process of lifting or sinking air. Also, those are things that have big impacts on the type of weather you see. Diabatic cooling normally does not play a big role, but in this storm it did. One of the reasons that this storm had a bigger effect of diabatic cooling is because of the intensity of the snow. You know, if it was just a few flurries, but the snow was melting, it probably wouldn't have had much impact. But because the snow was coming down at an intense rate, there was a lot of that snow melting, and it ended up having a bigger impact on the atmosphere, just enough to keep it a bit cooler. So, the big question, could a storm like this happen again? Well, this was an extremely difficult storm to forecast and to anticipate in advance. For the reasons I've explained, again, this was a real challenge, and a similar storm today would also be very difficult to properly diagnose. Given the highly complex and sensitive nature of the storm, even if you did know it was going to be snow, nailing down a detailed snow forecast would still be very difficult because remember, those huge differences in snow totals over small distances are a real challenge to pick out exactly where that heavy, intense snow is going to accumulate. And we're talking about very fine details here. But technology, of course, has improved fairly significantly since 1987 and continues to improve all the time. Model data has gotten better, surface observations and the spotter network across our area dramatically have improved, and forecasters have learned lessons. We've studied storms like that, so now we know, yep, that can happen. So everybody's gotten a little bit better at tracking storms like this. The technology has improved, but the bottom line is occasionally Mother Nature's going to throw a curveball at forecasters that even today would still be difficult. You know, hopefully we'd be able to pick out a few of those features and we would have had at least a better sense that it could turn nasty. But again, it still would be a challenge to forecast a storm like that. Even today, just some combinations of Mother Nature that are really tough to read. So, do I think it would be possible in the future? Yes, but hopefully as both forecasters and technology gets better, a storm like that being misforecasted becomes less and less likely. So I wanted to leave you with this. Yeah, a very formative storm in my childhood, and in red, that is a 5-year-old Nick Johnston. In blue, that is my younger sister, Emily. If you're looking closely, Emily has a carrot held up to her nose, and the next photo will explain what's going on here. There we go. It was perfect snow for making snowmen and packing snowballs. Heavy snowballs, though, so you want to be careful with those. But we had an absolute blast, and this is what I wanted to leave everybody with. You know, obviously, this was a big storm. It was deadly. It did a lot of damage, both to property and to people. So a very serious storm, but, you know, for kids, all about perspective. And my parents were able to weather this storm and keep a good attitude about all of it. And you know, for us kids then, this ended up being a really memorable, really positive event. Now, I understand, parts of the viewing area who went dark for 1 to 2 weeks, patients are going to start running thin after about 1 to 2 weeks in the dark. So not everybody had it as good as we did here in the Capital Region. But yeah, I just wanted to give a shout out. Thank you to my parents for putting the storm in a good perspective for us as kids. And instead of it being a negative, it ended up being a huge positive. So thank you to them. And a thank you to everybody at home for joining me for this storm analysis. Wow, all right. Thanks, and again, hopefully we will never see another storm like this that catches the region off guard, but we'll have to wait and see what the future will hold this winter. Thanks.